In this lesson, we're going to take a closer look at quadratic equations and some of the methods that can be used to solve them. In the past, we learned that we can solve quadratics by factoring. But unfortunately, factoring doesn't always work, and there's 3 other methods that can be used. We're going to go through those 3 methods in this lesson. The first method involves using square roots. This is where you can get rid of a squared by taking the square root of both sides. The steps for this method involve isolating the quantity that's squared. That's already happened in part A. Then we take the square root of both sides, but we have to include a plus or minus to indicate that whether you square something that's positive or negative, you get the same thing. Taking the square root gets rid of that squared on the left-hand side, so I'm just left with x minus 3. And root 25 is 5, so x minus 3 could equal positive 5 or negative 5. This is actually 2 equations that I need to solve. In both cases, I have to add 3 to solve. 5 plus 3 is 8. Negative 5 plus 3 is negative 2. So I have 2 solutions, 8 and negative 2. Let's look at one more that's similar. We isolate the squared quantity. So this time that means the x squared has to be by itself. So I add the 8 and divide by 2. Now I can take the square root of both sides. Don't forget that plus or minus. Square root of 4 is 2. So this problem also has 2 solutions, positive 2 and negative 2. Now this square root method only works if you can isolate all of the x's in a squared quantity. In other words, when you look at the equation, this method only works if there's one x in the problem, either an x squared or a quantity squared. So we're going to have to take a look at a couple of other methods. And our second method is called completing the square. But before I show you that technique, I'm going to review a couple of concepts from earlier in the semester. Let's start by remembering how we can FOIL out or expand a binomial squared. X minus 4 squared means we're taking x minus 4 times x minus 4. If I use FOIL, my first is x squared, my outer and my inner add up to be negative 8x, and my last is 16. Notice the 8 is 2 times 4, and the 16 is 4 squared. Recognizing this pattern, we can go a little bit faster. X plus 5 squared can also be FOILed out, but the first term will be an x squared, and the middle term, well, we can get that by doubling the 5. 2 times 5 is 10, plus 10x. And then 5 squared is 25. That pattern will continue anytime you square a binomial. So if you have x plus a number, which we'll call x plus n, the first term will be an x squared. The middle term will be whatever 2 times n is, and there'll be an x there. And then the last term is n squared. So we're going to use this pattern to create what we're going to call perfect square trinomials. So again, notice the middle term is 2 times the number, and the last term is the number squared. This process of creating a perfect square trinomial is called completing the square. So I'm giving you the first 2 terms, x squared plus 14x, and we want to figure out what number would turn this into a perfect square trinomial, something that can be factored as something squared. Well, the pattern is the middle term is 2 times the number, and the last term is the number squared. So in this case, if my middle term is 14, that number, the n, is 7, and n squared is 49. So if I add 49, this is now a perfect square trinomial, and I can factor it as x plus 7 squared, x plus n squared. All right, so let's summarize that pattern in the next example. To complete the square, we look at the number in front of the x, we take the number in front of the x and divide it by 2, and then we square that number. 12 divided by 2 is 6. 6 squared is 36. So to complete the square, I have to add 36. This is now a perfect square trinomial, and I can factor it as x plus 6 squared. You can always check your work by FOILing out your factors and making sure you get what you started with. Same pattern for the next one. We're going to look at the number in front of the x, and I usually ignore the negative sign and just deal with that later. So I'm going to look at the 5, and I divide it by 2. With completing the square, you really want to work with fractions instead of decimals. So I'm just going to leave that as 5/2. Then I take that number and I square it. 5 squared is 25, 2 squared is 4. So to complete the square, I have to add 25 over 4. In factored form, this is where I'm going to pay attention to the signs. Because I had a minus sign, x minus 5x, the factor is going to have a minus sign in it. And it's going to be x minus our n, which was 5/2. So this factors to x minus 5/2 squared. So I've written down the steps that we're going to use to solve these equations. Feel free to pause the video if you find it helpful to write this down. We're going to start by moving the constant to the other side. So in this first problem, that means adding 7 to both sides. Notice I left a little bit of space so that I have room to complete the square. That's step 2. So to complete the square, I look at the number in front of the x, and I divide it by 2. 8 divided by 2 is 4, and then I'm going to take that number and square it. So to complete the square here, I'm going to have to add 16. Now because this is an equation, I have to make sure I do the same thing to both sides. So I'm going to add 16 to both sides of my equation. That was step 2. Then step 3 is we factor our perfect square. It'll become x minus 4 squared. Notice this is where the negative sign stays. It was a minus 8x, so it's a minus 4. And 7 plus 16 is 23. Now we can actually use that square root method. I take the square root of both sides. Don't forget that plus or minus. So x minus 4 is plus or minus root 23. 23 is not a perfect square, so it's just going to stay like that under the radical. But to finish, I add the 4. Now, root 23 and 4, we can't combine those. Those aren't like radicals. So we can leave our answer like that. You can also put the 4 in front. Sometimes that looks a little bit nicer. Technically, we have 2 solutions here, 4 plus root 23 and 4 minus root 23. All right, let's try the same process with a different example. Step 1 is move the constant over, add the 3. Then I take the number in front of the x, the 5, and I divide it by 2. I want to work with fractions here. So 5 divided by 2, I just leave that as 5/2. I square that number. 5 squared is 25, 2 squared is 4. So I have to add 25/4 to both sides. Step 3 is factor. This one has a plus sign because it was a plus 5. And it's always going to be x either plus or minus whatever your n was, or whatever you squared. So this one is x plus 5/2 squared. Now I do have to figure out what 3 plus 25/4 is. I'll get a common denominator to do that. Let's see, 12 plus 25 is 37. So 3 plus 25/4 is 37/4. Now we take the square root of both sides. Don't forget that plus or minus. It gets rid of the squared on the left-hand side. On the right-hand side, 37 is not a perfect square, so the 37 stays inside the radical. But 4 is a perfect square. Square root of 4 is 2, so we'll have a 2 on the bottom that's not inside the radical. Finally, to finish, I subtract the 5/2. Doesn't matter if you put that in the front or in the back of your answer. And that's it. You can leave your answer like this. Because you happen to have a common denominator of 2, if you want, you can combine it into a single fraction. Minus 5 plus or minus root 37 over 2. But you can't combine the minus 5 and the root 37. Those are not like radicals. All right, that's the technique of completing the square. This method, it really just takes practice. I promise it'll get easier the more problems you try. If this didn't make sense, feel free to come to office hours or send me an email and maybe I can help clear it up a little bit more. Now I have one more method I want to show you, and that is called the quadratic formula. So the technique of completing the square is a method that always works. You can solve any quadratic equation by completing the square. However, sometimes it's kind of a pain. As you saw in my second example, we had to deal with fractions, and if the problems get more complicated, the process gets more complicated. And so I have written down in the notes what's called the quadratic formula. And this really is just a formula that tells us what happens when we complete the square if we start with a general quadratic equation. So a would be the number in front of the x squared, b is the number in front of the x, and c is the constant. In this class, in Math 055, you do not need to memorize this formula. However, if you're planning on, which I assume you are, taking Math 121, you will need to memorize this formula, so it's not a bad idea to start to become familiar with it right now. All right, let's see how it works within an example. So the first thing I want to point out is this formula was derived assuming your quadratic equation equals 0. So before you do anything else, you want to make sure the quadratic equation you have has one side equal to 0. In this case, this means we have to subtract the 4. A is the number in front of the x squared. In my example, that would be 1. B is the number in front of the x, -3, and C is that constant, in this case, -4. And now we just have to plug those numbers into that formula that was given to us. So in this formula I have circled, everywhere I see a B, I've replaced it with a -3. Everywhere I see an A, there's a 1. And everywhere I see a C, I put in a -4. And now I just have a lot of arithmetic to do. -3 is a +3. -3 squared would be +9. -4 times a 1 times a -4. 2 negatives there make it a +16. 9 plus 16 is 25. Root 25 is 5. 3 plus 5 is 8. Divided by 2 is 4. 3 minus 5 is -2 over 2 is -1. So I have two answers, 4 and -1. Note, in this case, I could have actually factored this problem. Product of -4, sum of -3. I think that would have been quite a bit faster. But it's nice to see that we get the same answer with the quadratic formula. All right, let's try another example. The nice thing about the formula is it works in problems when you can't factor as well. So for part B, we're going to set one side to 0. That gives me 2x squared minus x minus 5. So my A would be 2. The number in front of the x is a -1. And C, the constant, is -5. I plug all of these numbers, the A, the B, and the C, into that quadratic formula, and then I have a lot of arithmetic to do. -1 is a 1. -1 squared is 1. And then once again, we have two negatives there. -4 times 2 times -5, that'll be a +40. And 2 times 2 is 4. So this becomes 1 plus or minus root 41 over 4. And that's it. We actually can't go any further with this problem. Root 41 is not a perfect square, so we can't combine any terms. And I'm just going to leave my answer like that. All right, so to summarize, we learned 3 different techniques to solve quadratics. You can take the square root of both sides in some special cases. You can complete the square. That always works, but it's kind of a pain. Or you can use the quadratic formula, which is also a long process, but also always works. In this lesson, you're going to practice these 3 techniques, and then in our final lesson, we'll talk a little bit more about how do you decide which method to use. Once again, I know that was a lot of material. Don't hesitate to ask me if something is confusing.